Because if you are forecasting, let's say, the total amount of veggies on one hand, but on the other hand, you are also forecasting how many carrots and how many tomatoes or whatever you need to buy, then these numbers will not match. And there are ways to make them consistent at the end. But
welcome to Data Breakthroughs, the podcast where every episode starts with a mystery. My guest and I walk in blind. No clue what the problem is, no idea about the industry, and definitely not here to spend an hour debating tech stack. Instead, we unwrap a real problem from a real person, figure out what's actually going on, vanish for 15 minutes to think on our own, and then return to see if we can crack it live. It is part detective story, part improv challenge, and part let's see what breaks. No scripts, no preps, just curiosity, creativity, and a dash of chaos. Today, my partner in problem solving is the wonderful Irena. Hi! So happy to have you here today. How's it going?
hello, I'm good, thank you. Nice to be here with you.
Would you like to introduce yourself first?
Yes. Hi, everyone. My name is Irena Bojarovska, applied scientist at Zalando. I've been living in Berlin since 2012. I did here my PhD in applied mathematics in TU Berlin, and since 2017 I'm at Zalando. I was first an analyst, now I work as an applied scientist in the field of forecasting, time series, more particular demand forecasting. Yeah. My private life, I'm a mother of 3 small children. I am also teaching math for a small, like a math club. I come from Macedonia originally, maybe also interested.
Thank you very much. Before we start with our problem today, we've prepared 3 icebreaker questions for you. Are you ready for them?
Okay.
Would you rather explain a p-value to a toddler or machine learning to your boss?
I think I can do both, I guess. With the p-value, it depends on the age. But if the kid is a toddler, that I can understand circle. If they have seen an orange or a plate, I think it could be well explained in this, let's say, direction. But I feel that it's as valuable to be able to explain simple concept to people. I mean, my boss, I think he would not need to explain machine learning, but let's say someone else boss or someone from not a technical department, I guess it can be tricky, but I think also doable. And I guess what I did at the conference that I did just last week is that I was actually combining both. So I was explaining machine learning concept of time series reconciliation using a birthday party of a toddler as an example. Well, I think because I got a very positive feedback afterwards.
That's cool. You know, one of the things that I realized many times is that non-technical people, when you're explaining it in simple terms of, I don't know, how to run a restaurant as a data team,
yes,
it's catching much better.
Exactly. So my catcher was birthday party planning.
That's cool concept. Maybe I steal it the next time. The second question we have prepared for you to the warm-up is, would you rather have infinite clean data or infinite GPU power?
Definitely infinitely clean data. I'm happy to wait for my results when I am pretty sure that I'm responsible for my work and this is something that I can control. Data quality is usually something that I cannot control and I have to trust and accept most of the time. And I would be very happy to be able to make a tick box over there. Try out maybe in smarter ways to fasten my algorithm if needed.
And the last question, which is the interesting one. Would you rather fight one giant overfitted model or 100 teeny underfitted ones?
Yeah, this is a difficult one.
Ah.
I would take the giant one. I think there is an opportunity for improvement once you have everything in one place. But actually, I'm not sure. Maybe I can change my mind. I am not sure.
No, not changing. That's it. No. We sold you the giant.
Okay, then we go for the giant. The thing is that this is something that if you are able to solve, then your work is kind of done. And you have much less to think because you have only one model that is suitable for solving a lot of problems, but at the same time, you have the risk, right? So at Zalando, we do demand forecasting on a market level. So Germany, Austria, Switzerland, at the moment, we have more than 22 markets. And it's always the question, do we try to have one model for all of them and hope that they learn from each other? Or we have each country separately, which can be very small because we are launching some markets this year, last year, so barely any data. And still, these tiny solutions are working better for some reason. But I think I wish we could have tackled the issue with the giant model. So maybe that's why I went for it. I think the truth maybe then somewhere in between if one can maintain both. But yeah, very interesting topic. It's exactly mine.
And after this warm-up, are you ready to see our problem today? So the problem we are facing today is as follows. During our company hackathon 6 months ago, a team of our developers got frustrated with our office food waste and built a smart kitchen demand forecasting model to predict how much fresh food to order for our office meals. I like it already. How much fresh food the office needs. The model showed impressive accuracy of 91% during their 2 weeks prototype, but we are still throwing away 20 to 25% of fresh products weekly while running out of popular items. Nice problem to solve. What do you think about it?
I think it's super interesting and it goes exactly aligned to my birthday party catch from the conference last week, because there I also spoke about at the end optimal planning. At the end of a birthday party, you also don't want to run out of beers, and you don't want to have a stock of chips for your next 5 years and so on. So yeah, it's a real struggle, I think, in everyday family life, but also in companies. So in every level, actually, very interesting problem. I love it.
So this is the start. They're throwing away on us. They're already saying that it was accurate and at some point it drifted. And they're still throwing 20 to 25% of fresh products. Let's see the situation. We provide catered breakfast and snacks for all employees. As a company benefit, the hackathon team was tired of seeing perfectly good vegetables and fruits going bad while colleagues complain about missing their favorite items. They built a model using historical food consumption data, employee calendar events, weather data, and even Slack sentiment analysis. Everyone was excited about our AI-powered office kitchen. I'm already seeing here some things that scares me. First, weather forecast, which never work. I don't know why people keep referring to this as something that is helpful. And also the data from Slack, which is interesting for me. I don't know which data they're using. Let's see if they're giving more information here.
I would assume that this is about like when people complain, oh, there was again no yogurt that is vegan and whatever, and then they take this information out, and then yeah, the frustration of the people analyzing it. Yeah, I guess.
The trigger last week was especially frustrating. The model predicted we would need extra salads and fruits because it was sunny weather, and several teams' meetings were scheduled. But then half the development team worked from home due to a client emergency, and the remaining people were stressed eating comfort snacks instead of healthy food. We threw away 400 euros worth of fresh products while ordering emergency pizza because we had no satisfying food left.
Wow.
You know, it reminds me the days that I used to work and back then we used to have breakfast, and each day there was like properly prepared breakfast with eggs and like crazy stuff going around. And a lot of this food used to be thrown away, or people just didn't go to lunch because there was so much left from the breakfast. And this is the same thing. I don't know if it was in the same levels of 400 euros, but it was quite expensive back then as well. Then there is a tension. The sustainability team is disappointed because food waste was a major company goal for this year. The developers who built the model are frustrated that their weekend hackathon project is being blamed for not working perfectly. Meanwhile, I'm stuck between trying to be environmentally responsible and making sure our team has the food they actually want. The CFO keeps asking why our AI solution isn't solving the problem. The boundaries. The office catering benefits is essential for employee satisfaction in the competitive tech market. We cannot overstock fresh food due to budget and sustainability goals. The hackathon team created a model with limited ML expertise in their spare time. There is no budget for hiring data scientists or making major infrastructure changes. We need to keep food quality and variety high. order must be placed 2 days in advance with suppliers. So we have our boundaries, we have our tension, we have situation, and we have a trigger. What do you think about the problem?
Yeah, I think it's a real problem. And I like that the company is trying to solve this problem and also trying to then optimize, let's say, for a better solution, seeing that it's not perfect. I think already they're on the right path. Of course, I find the boundary that they don't have opportunity to hire data scientists very tough one. Because it's like I want to have an operation, but I don't have a surgeon. Can the medical staff try to do it instead? I think that's pretty hard one. So you have to see how to solve it given the circumstances.
I think we need to think about going around the drops of how we optimizing this model and figuring out how we creating an advantage without creating more work for the people. That's the main boundaries that we have. Our job now is to create a clarity statement on what we are solving, what we are not touching, what we are assuming, if there are any assumption. Should we make it about setting up the data for the model, reassign it? Is it more about how it's being used? Where do we want to actually focus on our problem?
Yeah, it's a good question. I think so. Here, my first question is like, is there an opportunity to at least monitor the model or do another batch of retesting and re-evaluating the model? Assume they need to retrain it every week, right? For in order for it to produce some results. So there has to be some level of maintenance. So whoever is one who is running the model or wrote the model in the first place during the hackathon, I assume could touch it a little bit. Or do you think this is a boundary? Because they say they can't hire more data scientists, but doesn't say that they cannot work on the model a little bit.
They can work on the model. We don't have any more information than what we have here. We can define what problem we solve. We don't need to go directly to the solution yet.
Yeah, okay.
And we can make whatever assumptions we want to do. So there is some confidence level dashboard. But then the question, isn't it already solving our problem here?
Yeah, okay, good. No, I mean, yeah, we should not do this, but I think definitely setting the problem as it is. This.
I think that what we can do here is to say that we cannot completely solve the 20 to 25% waste of food. We won't be able to completely eliminate it because it's still a model. This is one of the things that we need to put an emphasis on. And in our problem, maybe we can say that we're trying to reduce it to a more acceptable level. So food waste is no more than 10 to 15%. And then by that, we're creating some kind of, there will always be waste of food. You cannot do it zero, but at least we improve the model by 10 points. What do you think?
Yeah, I agree. And I think in general, the statement should be that it's about improving the model because that's the only thing that can drive a change. And this is broad enough to later discuss how we want to do it.
Yeah. So we will try to improve the model by decreasing the waste by 10 points from 20 to 25 to 10 to 15%. We won't talk tech because we don't know what is the infrastructure. We don't care about it, actually, to be honest, for this model. It can also run locally on somebody's computer. And then increase, this is something I'm adding here, and tell me what you think. Increase the trust in the model by the users and improve overall, now I'm bubbling bullshit a little bit, but improve the overall food consumption in the company. Because what we can also discuss here about is when we see that there is a little bit of over-ordered, we can also market for people or figure out ways to share the love with the food with people that are going to enjoy it. And then it's not going to waste, just as an idea. So we have here quite wide space to walk around.
Yeah, I agree. And I think everything that comes into my mind now are plenty of ideas how to improve the model. So that's why we don't need to go into details here. We can keep it for other.
This is the problem space. We don't talk solutions yet.
Exactly. So
honestly, I don't have yet an idea what I'm going to do in the solution space.
Yeah. It's okay.
If we don't have any other things that we need to add in here and we're feeling comfortable with this statement, are we going to the break section and turning off cameras for 15 minutes?
Okay, sounds good.
Then I see you here in 15 minutes.
Okay.
We are back from the break. How was it?
Hard. It's hard to think of everything that you have to think about in your everyday work, but now at once, in a 10 minutes or 15 minutes time, it's not so easy because, there are many things that are hidden and that one doesn't think of. So, I'm sure I haven't missed anything, many things, but it was still, it was a great exercise.
You know what is the beauty about it? This is not an interview. So there is no right or wrong.
Yes.
There is only a breakthrough. And I think this is the important part here. And I think that I see quite 2 full boards that can be used. So maybe would you like to start presenting your board? I'm going to follow you.
Yeah. So let's start with the first part. In the brainstorming area, I would first share the quick wins that I could think of. I read that there was Slack sentiment analysis used, which is something that I assume it's about people's feeling about what happened, but the damage has already happened. So I think it would be maybe more helpful if people on a free basis, of course, not required, just share their plans for the upcoming days, and that this data, this is something that is called future covariates. So it's some data that is helping our forecast, for which we also know the values. For example, for demand forecasting, it can be the planned discount rate. This is something that we plan. That the colleagues give this information shortly. They prefer pizza because they're under stress. They want more salads because it's hot. So they say it, and there is a time for the model to learn. So this is something that I added, and there are many models who accept such future covariates and can improve the model by large. Then the second one was again about the data. Basically, data is the key for forecasting, right? So then if there is a calendar, it was written that the calendar is used. At Zalando, we can always mark if we are working from home or if we are working at the office. And you can make one like a general, what's your usual pattern? But if this pattern changes, you have to change it manually. And this is something that I can well imagine that people forget to do. So in their normal home day, they decide to go to the office. In their normal office hours, they stayed at home. People need to be reminded. We also have a very interesting parking planning slot system. And there was lots of frustration because people would book a parking and then end up not coming. But there was no reminder. There was only an email afterwards, hey, why you didn't come and you have reserved the place? And then I forgot to cancel it. And now an email comes in the evening before, are you sure you're going to use your parking tomorrow? And this helps a lot. Planning is the key and getting the right data. On the forecast, there was one error. So we have this accuracy, but we are ordering many things. Where is our accuracy good and where is it bad? This is something that is good to decouple. Is our accuracy on salad very bad and accuracy on, fresh juices actually quite okay? Also, seasonality pattern. I could well assume that accuracy on a Friday is much worse because, or maybe very stable because just no one comes. We don't deliver anything. We are perfectly accurate. This is something that needs decoupling and seeing a little bit the more zoomed in picture. And then one thing I added is that, it's an AI method. It's cool. And I believe that this is very exciting, probably was very exciting for someone to work on. But what we see is that often simple statistical models work even better. I would try something very simple, no fancy covariates or anything like this, like no fancy additional data, just a simple historical data and try to forecast it. For if this delivery has been tracked for a while, there is enough data, maybe this is even better. Then if we go to the blue one was the idea. So this is regarding how this error was calculated, and there was mentioned something about the 2 weeks prototype. So the problem with the time series forecasting, what many people don't realize, but it's not their field that they have worked in, is not like usual machine learning where you teach a model to recognize a cat and then you just give a bunch of untrained images and then it has to guess. You can't do this in time series so that you give 2 weeks or even a month or 2 months of unseen data, because every month has its own seasonality. Maybe during the summer holidays when everyone is taking holiday, it's much harder to predict than, or Christmas, let's say, than some stable months like spring or autumn. So that's why we need a model that is going to be equally good both in the Christmas holidays and around summer and in winter and spring and so on, or at least on average the best among the rest. So that's why it's important to revise the model and make sure that we have trained for, not trained, but tested on a full year. So this is what add-on that could be possibly tried out. And here again on how to do it, maybe it's hard, boldly said, but most of the known and well adopted time series forecasting models. So one does not need to collect each from a different Python package, which can be very difficult because each of them requires different input data, different type of data, and it's a very, very time consuming. But with these libraries, you prepare the data once, and then you can try out with the same setup, like 6, 7, 10 different models with very minor changes. And most of them even have default parameters. So given the constraint that I also wrote here on the side, that there is no budget for a data science team, still someone with a little bit of excitement about the field and willing to learn and invest some time on it could do very well with this kind of ready-to-go packages. And then I think only the what is rest is how to incorporate the reasons for bad forecasting back to the model. So we saw there were these situations where people were under stress and so on. So maybe this is a learning. I mean, it's important that this data is collected, but then one has to think how to put it back. And sometimes there are some methods we call it backwards explainability, like how to explain why the forecasted what it forecasted. But I have to say this is quite difficult. And then I added one here that I afterwards thought actually this is the first thing to do. That is to do exploratory data analysis on the data quality. I mentioned also in one of the first questions that you wrote me. So all of these things like this sentiment analysis, even the historical data itself, the weather, as you also mentioned, it has to be checked. Okay, do we have stable data and can we trust this data? And is this data in a way forecastable? So, and for this also, even if one searches for EDA, notebooks on the internet, you can find some templates and just use them and then try to see what the analysis is telling you. Are you having good chances for a good forecast or not? Yeah. On the architecture side here, this is maybe kind of self-explanatory and of course very simplified, but usually what one would do is that we load the data, we pre-process it in some way, we prepare it for the modeling, then we train the model. This is another thing. It's often a good question. How often do we train the model? Because we get new data, and ideally, if the simple model doesn't require like hours of training, that I would retrain every time, because then there's just more chance that the model learned a little bit more. So the frequency of the training is a good question. And then we forecast. And finally, a most important one that usually data scientists don't want to deal with because it's kind of boring is to still track how was your model, because it's for me it's the best one of the best parts about working in forecasting is that one can track the accuracy of the model. And of course, if the error was bad, it does not necessarily mean the model was bad. Maybe the model just did not capture the changes that happen between the training time and the actual event. But then it's still an opportunity to learn how could we foresee this, or how could we learn this well in advance and put it in the model.
I love this. The reminder that you said about this 2 days in advance. I think this is, if there is one thing that I'm taking already out of it and I'm saying this is something I want to take with me, it's this one, because it's so simple. And at the same time, it can create such a huge impact. And about the error analysis, I know the data scientists usually coming and saying, I'm doing 80% innovation and then 20% is maintenance. And they're forgetting the part of the error analysis, because it's
not even included. Yeah.
It's not part of my job. I'm just doing innovation here. But I think it's a good segment to my solution board, which I think here we're going to see a little bit the difference between a data scientist and a product manager perspective, because mine is a little bit different in the way that I approached it. And one of the things that I started with is actually trying to understand actually what's going on here from architecture wise, right? So we said that there is Slack data, there is weather data, historic orders, and calendar that's flowing into some model. This model doing some mambo jumbo magic, as we want to call it, and it generates an order recommendation for salads, fruits, veggies, others, whatever it happens there. This was my starting point. And then I started to think, hold for a second and think, what is actually the cost of this problem? What is the actually cost? How much it actually costing the company? Is it actually worth running this model and give it so much information? Or rather, we can reduce this information and make it a little bit slimmer and be much more accurate by breaking it down. So this was one of my main concerns. Then I was thinking about it a little bit more, and I said, what is a good waste level for a company or in general? Because they saying here 20 to 25 is going to waste. Is it actually good or not? What is the benchmark? What is the average in companies? And what was actually the average in before they had it? Was the model actually solving the food waste problem? Or was it improving it? Or was it doing anything there, or actually worsen it? And I think this is something that we are missing in the information, and I would have loved to have it. From the constraint perspective, there is no way to reduce the waste to zero. Both agreed on it. I think there is no chance to do that. And we need to put it as a constraint, and then we can't hire someone. So we understand that we're not able to do it. Oh, I didn't put my timers. Starting now. And then we put in the constraints when these two. And then I was starting to think, okay, how can we actually solve it? The first idea that I had is confidence level of the models, giving the human the decision power. Is the model is confident enough in the prediction or not? And if not, let the human do it. And if this is working well, then great. The other quick solution is recommendation-based XY, so explanatory. Why did you make this decision? Why did you say that I need to order now 15 bananas and not 35? So give the rationale of the decision flow, which I know from data science perspective, it's going to take a lot of time to actually add all this information. It's going to make it very complex. It's not really a quick solution, but it's easier to do that. And then another one that I was thinking about is why not to conduct an A/B testing? Let the ordering team order from time to time, place the order without the model and with the model and see basically what is the difference, what's going on there. Are they more accurate or not? And then sit with the team and understand how did they make the decision. So analyze basically the way that they making the decision. Is it really weather? Is it calendars? Is it just a gut feeling that they had in the morning and they said, like, I think that today we're going to place more bananas than we ordered before? And then creating some baseline waste over time. So it's helping us to understand also, are we improving, are we not, and who is making the better orders. So this was one of the lines that I had. The other one was break the model into smaller categories. I wrote here salad yogurts, which is very bad because it's very, very small. But for example, veggies, fruits, and milk products, for example, or milk replacement products. And then based on it, creating some kind of better analysis for each of these categories in a better way. The other option that I have is removing the weather forecast, because to be honest, I don't think I ever seen any model in my entire career that used weather forecast and gave some value. Sometimes, and we know it because we live in Berlin, you can be in northern Berlin and it's going to be raining, and you can be in South Berlin and it's going to be sunny. So which forecast are you actually taking? If you need now the accurate location of the office, I think it's just making it a little bit too complex and too complicated. And we also don't know the size of the company. Do they have only one office? Is it more than one office location? So there is a lot of interesting things here that we need to think about. And then change the size of the sample may be also going to have some impact, because maybe it's actually the size of the data that it receives that throwing it away, and changing the size of it will make something better. But that's my perspective on possible solution for that. And I'm done, basically.
Good. I like your ideas a lot.
Yeah.
Okay, before we go to the next step, so you are right that we can't reduce the waste to zero. And what it occurred to me is that, I mean, now thinking, let's say now I go in this like product brain a little bit myself. The thing is that assuming we can't reduce it completely, is there a way, if the goal, the overarching goal of the company is, let's say, to be more sustainable, to be, because we are not speaking here about cost saving or something like this.
Correct.
It comes more on the sustainability side. Then why don't we, and this will be not the task of a data scientist, but of someone else in the company, come up with ideas what to do with this food? Because they write they are great veggies and so on. In Berlin, there is like a Too Good To Go, an app where you can register and get stuff, or every colleague can take some for home, but I guess then it will not be visible that it stays. I guess this is not really working, but there are ways of have a collaboration with some volunteer organization. So in that way, improve and even turn it more to a success story afterwards if the applied scientists are not perfect in their forecasting. This is one idea that I got. Another one about the confidence level. This is very important one in forecasting. And another thing that is very important is that there are some models which are probabilistic where you can say, what do you prefer more? Do you prefer to order more and risk of having overstock, or do you prefer to order less so then is no food waste, but at the same time people might get frustrated because they didn't get? Of course, ideally you don't know and want any of it, so then you can go for the average, let's say. But if they understand that one of them actually is more important, then one can steer the forecasting in a way that it gives you a forecast that is a bit more, how to say, generous or a bit more skeptical.
It reminds me that when I worked at Zalando back then, in the upper level, there were, so the floor above us, it was developers. And we knew that whenever they're announcing that there are fresh veggies and fruits arriving, they never touch it. So whenever we ran out of bananas, we just took our box and we went upstairs. We left our box there and we took theirs.
In this case, a survey maybe would have helped, because I'm sure they are happy to say what they prefer. And one thing last thing I wanted to add about the different categories, this is actually niche. So I do demand forecasting, but in the last year and a half, I was working particularly on something called hierarchical time series forecasting or hierarchical reconciliation. It happens way too often, almost always in a forecasting problem, that you have some natural categorical tree-like structure of the things that you are forecasting. And it's a whole pleiad of different models who are able to do the things in a different way. So you could even put everything into one model, but in a special hierarchical model where the structure is known, and then the model tries to forecast everything, but that everything together, but take into account this categorization. Or, as you say, you forecast everything independently, but then you do a second step, which is called reconciliation or consolidation to match the numbers. Because if you are forecasting, let's say, the total amount of veggies on one hand, but on the other hand, you are also forecasting how many carrots and how many tomatoes or whatever you need to buy, then these numbers will not match. And there are ways to make them consistent at the end. But I guess in this case, since there are no data scientists and it's not planned to get them, maybe it's not that straightforward. But to just decouple and try to forecast separately, it's a good idea.
Maybe we found the problem of the $1 million, for the investment in this problem that they just gave us. I believe a lot of companies will love to have such a model on board.
Yeah.
Cool. We are ready, I would say, to continue in our funnel now and start refining it. What we're going to do now, we're going to turn off the cameras, have a few minutes to draft our 3 insights, 3 actions, and we will be back again to discuss it and then create the final. Okay, back from the insight refinement. And I see you have already your 3 insights and 3 actions. Would you like to start taking us through them?
Yes. I wrote my 3 insights in the following manner, because the question was how to improve the model. If we pose the question like this, then we could find 3 pillars. One is improve the data input and the data quality. And for this, we could provide the employees an opportunity to answer short questions and have then their food preferences for the next days on one hand, and on the other hand, there are preferences or plans for coming to the office or not, and use this future information about the future from first hand, so to say, inside the model, and make sure that the employees are notified in advance to answer this. A second way to improve the model, to improve the forecast, is trying out different models. AI is great, but and here I even advise to try out a thing called foundational models. So actually they are models based on LLMs, like, as we know, ChatGPT and everything else. There are models that are able to forecast, that has been trained on huge amount of data from a variety of sources. So they are pretty cool. They are very straightforward to use. So it's a way to explore, but definitely we should not forget about the very simple models, even without using any additional covariates or information, but just the historical data. And then naturally, once we advise, try out different input data, try out different models, then the question comes, how do I choose then my model? What do I want to go with in production, right? And for this, we need to have a very clear, let's say, understanding what is the best way for us to measure the accuracy of the model and to be able to at least closely be confident that what we have promised is what is going to happen, right? Because this is the issue that we saw. Their accuracy, that was when they were on the test time, was great. But when the actual time came, the forecast turned out to not be able to predict at all. So that's why we need to test on a full year of a cycle first. And second, once the forecast is out, measure its accuracy and keep monitoring it. And keep also noting down it didn't work because this. And then how can we make sure that it doesn't happen next time?
A lot of manual work I see here.
So if there are some analysts, if no data scientists, then they can do the work and it's lots of fun. Why not?
I think it's still giving you quite good understanding, right? So the moment you're writing it down and you start explaining why something was failing or not, it's part of the learning to actually improve yourself to the future. So I think it's important, and people may say it's a lot of manual work, but it's at the end of the day, it's going to worth gold long term.
Exactly. And I have to say it's a manual work at the beginning when there is no working system. So for example, at work at the moment, we have built a huge forecasting infrastructure where everything is in place and everything is automated. And this thing of adding new data or trying out different model and hyperparameter optimization of that model, it's a matter of like this 2 changes and then it all runs and then you get your number at the end. Then the manual work is not there anymore because we have did a lot of work preparing, let's say, this whole infrastructure.
Yes. I think that this is how you simplify it long term when you have the resources. And I think here we still have the limitations, so we need to think about that.
This is maybe just a motivation of, let's
Where
say,
to go to.
leaders. Exactly. Especially if one could think of other applications, because maybe it's worth adding. And this is something that if I could speak to the CEO, I would say that we are here not solving the food problem. We are building an infrastructure for solving almost any problem at the company where good planning is required.
I completely agree on it.
And then one can think, okay, do we maybe want to invest? Not because of the food, but maybe because of the difficulties in planning in something else.
Yeah, I completely agree in here. And still, I think this is our €1 million startup. Just saying. On my side, I think a lot of the things that you mentioned, I also covered. So the simple things as asking people to advance if they plan to come to the office in advance. Sorry, why I wrote if in. No, if they.
No, it's your brain.
Yeah, I think so. So plan to come to the office can help us work with the forecast. So I think this is one of the points that you mentioned as well. And then understand better the patterns to react to changes if possible. So I don't know, when people saying yes and no, and what is the percentage of people that says yes and didn't show up, and so on and so on. So all these things can be factored and can be added to the model. And to be honest, I think this also can be quite a lot automated, right? So the only thing that is we're missing is somebody scanning his card when he entering, but we need consent for this. So I'm not sure yet how to do it properly, but it can be done. It can be done. Then the second insight that I put is the ability to insert the bad forecasting. So for me, this, for example, was something that I didn't even think about it. To insert each time that there is an error and there is a problem, make sure that the model is aware of it so it can also learn from it. I think this is another insight that I'm taking out of this episode, and check, and then from action point, check for data quality, because at the end of the day, it's all starting and ending with the quality of the data that we're using in these models. Maybe the forecast is bad and it's not showing the right data, or maybe even the old orders is corrupted. There is so many things that can go wrong, and we should actually validate it and check it. And I didn't see any point, and this is now what I realized when I was writing it. There was nothing about, did they validate the data in advance? Did they check it? Did they prepare it in some way? Or they just throw the data inside and offer something good? And I think this is one point that is worth talking about. From the inside perspective, what is good food waste? It's still sitting on me. What is actually a good benchmark for this? I don't know. Do we actually have an issue with 20 to 25%? Maybe this is a normal thing. I don't know how it happens. I don't know in bakeries. I don't know what happens in shops and so on. And I don't know what happen in other offices. Maybe it's actually quite good, and in other places it's 50% or 60% even. So it's worth checking this and asking, is it really a problem or not? And then also in an action point I wrote here, like, do an A/B testing, give humans versus machine and see what works best and why. And I think this is also, and again, to get this benchmarking somehow reduced, is by giving humans to make the decision and then see when a human is ordering, we usually have, 60% waste, while the machine is 20-25. It's already an improvement. It's 40 points improvement. So why not to go in this direction? And this is basically my 6 points of the 3 insights and 3 actions. And I think now we should go and move into the key insights. So we need to refine it. And I think that one of the things that I would like to take already, if you're fine with it, is the improved accuracy of the forecasting to improve the input data and the quality. I think this is one of the key insights that we should take as an insight out of this episode. Do you agree with me?
Yes, definitely.
So I'm leaving it in here. Would you like to suggest maybe the next one that we're taking into the insights?
I would say your first one about the asking of the people, because I don't know if this is more, it's an insight at the same time, it's kind of like an action point, because it clearly states what could be done. But I think it's a very important one, because then again, it's related to data, right? It's a one way to provide hopefully reliable data. Yeah. And then another one that I would put is the accuracy and the quality. And I guess here, I mean, yours on the A/B test, human versus machine, it's already in that direction, because even if you want to do this, it's another way of measuring. So you measure the accuracy and you compare it with another model. And then again, it's a way on having a data-driven decision what to go with.
So we have already the first action, I would say, as well.
Yeah. And here I want to add that it's not only VC, there can be a third one, and actually it's the one, for example, that we have at Zalando, is that the humans are using the AI-driven forecast as a initial point, let's say, and then adjust it if they feel or if they see that there is a need for adjustment, or if they know the things that the model did not know because the model did the work, let's say, one day before or something like this, and then some additional information came. So they could also, do their work completely independently or take the AI forecast as an insight.
On some sections, like a hybrid approach, basically.
Yeah.
Which actually, this is where we're going now, right? With all of these LLM models, a lot of teams need to start becoming much more hybrid, using the machine, but still keeping the rationale of the human in the system.
Yes, exactly. It's exactly about this.
And if you allow me, then the next action I would actually recommend you is increase the input data for the providing. I think this is also something that is relevant as an action point to take from here. And it's also something that can be done quite easily and do not require a lot of work. And we still have one more spot if we have anything that we want to add in here.
I mean, if we assume that they are willing to invest a little bit more in changing the model, I would go with questioning the model and come up with a simpler model, maybe. Otherwise, or data quality, because data quality is also not written. Maybe that's even more important. And then the change of the model maybe will come at some point naturally.
I believe so. At some point, it will need to show up, right? The update and changes of the model. And the fact that nobody mentioned anything about data quality in the problem space, making me raise the question, was it actually happening? We have 3 insights, 3 action points. I'm actually quite enjoyed this session. I would love to hear what you're thinking about it as a last.
Yeah, same. I am now excited to see what will come out if one would implement all of these ideas and try to improve. I do think there is a huge potential. And I think whoever wants to tackle these issues, they are exciting and also not too difficult. Some things that are small changes that bring big value. So this is a good point that one could feel, let's say, good about the work also with the small steps. And the thing that we had briefly about think about how to deal with the food leftovers in a way that is not wasted. So why to have a way? Because you were asking like about how much. Yes, it's a good question. But then I would say, even if I know how much, why to have this waste food? Because I'm pretty sure there is a way to reduce the number further by finding a solution for it.
Agree. I'm leaving it in the follow-up topics as part of our outcomes of this episode.
Yeah.
I really enjoyed it. I hope you did as well. Maybe some less famous words before you go, where people can find you, any interesting project you would like to share, anything like that.
So yeah, everyone can find me on LinkedIn. I'm happy to chat, also meet around the Lando offices in Berlin. If someone is in Berlin, can also find me in most of the AI Guild meetups. That's my favorite Berlin-based also community for AI and data science and everything related. Keep being curious, I think, and asking questions on how to improve things. It's always possible. Thanks a lot for the invitation. I'm
Thank you
looking
for
forward
joining.
also to the next episodes.
And yeah, I will see you around. Thank you for joining. It was a pleasure. And I think we have quite interesting board coming out of here that people can actually use, which I think is the best value ever. Really thank you for joining. And I will see you in the next episode.
Yeah, thank you also, Lior. Have a good day.
Ciao.
Bye, everyone.
That's a wrap on another Data Breakthroughs session. If you enjoyed watching us tackle this problem, we would love to solve yours next. Head to the link in the show notes to submit your data challenge. You could be featured in an upcoming episode. If you're a data professional who wants to join me in the problem-solving hot seat, there is a guest form too. Thanks for listening, and I will see you in the next breakthrough. Bye-bye.